Hello students, welcome back. Now let's go to section 4, absolute value. Absolute value by itself is easy, defined like this. By the way, in grade school we used to do something like this. What if we have an absolute value of a negative number? In grade school we simply select the number part and answer it like this. But we're in college now, so let's go to the precise definition. When x is greater than or equal to 0, take x the same. When it is negative, then put extra negative. Instead of doing this way, let's do it this way. Negative of -7. You see, this number is -7. But put extra negative there to make it positive. In the end, we got the same thing, but why did we take an extra step? That's because that idea is useful for the next step, absolute value equation. If you have an x expression, there's no number parts, so you cannot throw away the sign or things like that. We are stuck with this, putting an extra negative. So that's what absolute value equation does, putting extra negative. Here's an example. Okay, we have a nice problem here, so let's work it out. So that's equivalent to, this thing is just equal to 7 minus 2x, like this. Or, that's equals to negative of 7 minus 2x. So basically, if positive, then stay the same. If negative, extra negative. So we have to consider two equations. That's what absolute value equations do. Same, and then extra negative. So we have two equations, so we're going to get two solutions. The solution itself is not too bad. You see, first equation, no parentheses to work on, just take like terms, it's easy. The second problem, we have extra negative, so we have to use some breaking up. Yeah, but after that, not too bad. We get x equal to -9. We have two equations, plus version, minus version, so we have two solutions. Always check your answer. Check your answer and plug those in, and works out fine. Plug in 1. We have 5 inside the absolute value, and then right hand side is 7 minus 2, works out fine. Plug in -9, works out fine. 25 equals 25. So I have time for another problem like this. Okay, let's do that. So basically we have one equation, the straightforward equation, and taking the negative of this, we have two versions. The original equation, just taking away the absolute value, or the one given by extra negative. Okay? Original, just throw away absolute value. Negative version. How about the first? 2x plus 1 is equal to 4 minus 3x. So flip everything to the right hand side here. So we have 5x. And then 4 minus 1. So I'm going to get 5x equal to 3. Oh, never mind. 2x plus 1 equal to 4 minus 3x. Flip 3x to the other side, 5x. Flip 1 to the other side. So we have one solution. but that's not really complete. We have to consider the second equation. 2x plus 1 equals to 3x minus 4, the negative version. Flip 3x to the other side, negative x. And then flip 1 to the other side, we have negative 5. X equals to 5. Did I do this right? Please check. We have two equations, plus version, minus version. So we have two solutions, plus version, minus version. Well, always check your answer, and let's go ahead and check. So plug in 3/5. And then plug in 3/5. So what do we have here? Inside the absolute value, we have 6/5 plus 1, which is 5/5. And then here we have 4 minus 9/5. So 4, that can be written as 20/5. So what do we have? 11/5. 20 minus 9, 11/5. Yeah, that works out. This is positive here, so I don't need the absolute value sign. So yeah, it works out. Okay, that works out. How about the second equation here? So absolute value of 2x plus 1 equals to 4 minus 3x. But then again, I have to plug in x equal to 5. This is going to be an easier computation. Plug in x equal to 5, so we have 11. And then we have 4 minus 15. So if I take this absolute value off, I'm going to get 11. But the right hand side is negative 11. No, it doesn't work out. So this one doesn't work out. This works out. Looks like we have only one solution. The other is extraneous. Always check your answer. Absolute value equation is actually easy. All you have to do is change this into two equations, plus version, minus version, and both are expected to be easy. Just linear equations. But always check your answer because things like this can happen. Yeah. Check your answer. And if you use computer algebra system, we have only one solution like this. Okay, so much for absolute value equations. And let's go to absolute value inequality. And we're not going to do too much here. Absolute value is less than something or less than or equal to something. And we have double inequality like this because absolute value, that's actually, basically, this is plus or minus. So in between. And absolute value is greater, then we get something far more complicated. And the latter case, green case, we're not going to consider that in this level. Even the blue case, this kind of problem will not really show up until calculus 2 after completing college algebra here, so even this is kind of pushing the envelope in terms of the level of importance. The green case, that's not something we are going to consider. Not coincidentally, I wrote only the standard blue case. Absolute value is less than something. Absolute value is less than or equal to something. I only got those. And let's consider those. Absolute value is less than those. So you can rewrite this as -7. And then what's inside the absolute value? +7 like this. How about the next problem? -1 greater than or equal to, less than or equal to, 2x plus 1 over 9. You're going to get that. You see, they both fall into this category. So the inside of the absolute value is between negative and positive of the right hand side. Solving these, well, we have some time left, so maybe one of them will do. And if I don't finish, the rest is up to you, because these are just review, something we did in section 3 just now. Okay, let's remove the denominator, multiply by 5, so we have -35, and 2 minus 3x, and +35. Now let's move 2, so subtract 2, then I get -37, -3x, and then subtract 2, 33. Finally, divide by -3, -37 divided by -3, 33 divided by -3. We have double negative here, so these become positive, and this one stays negative. But then again, it's customary to have smaller number on your left, larger number on your right. So it's better to write it like this. -11x and then 37 over 3 like this. Flipping the direction. By the way, the direction changed because I divided by negative number. In terms of interval notation, we can write like this. Let's see, did I do this right? Okay. Do I have time for the second problem? Chances probably not. I'll do a little bit and then I'll just call it a day. Multiply by 9. So we have no more denominator. Now subtract 1. So -10, 2x, 8. Divide by 2. So we're going to get this kind of interval notation. Okay, did I do this right? Yeah, okay. Okay. All done, all completed. Let's meet again in lesson 3.